In our bus example earlier, we've learned how to do some basic arithmetic operations like using the plus sign to add two numbers together. So if we have this statement here, integer sum is equal to 4 plus 5, that would do this calculation over here and would calculate 9 and then store 9 into our variable sum. For subtraction, which is the minus sign, like for example integer difference is equal to 6 minus 3, this one will store 3 inside the variable. Integers can also store negative numbers, and you can even write negative numbers directly like integer temp is equal to minus 20, which would store the value minus 20 into the variable. For multiplication, you can use asterisk sign, which would multiply 7 by 2 and store the value of 14 in the variable multiply. And to divide numbers, we use this / sign, like this double div is equal to 5 divided by 2, which would result in 2.5. However, even though we are storing the result in double variable here, because we are dividing two integers 5 and 2, the result would also become an integer, throwing away that fractional part and only storing the value 2 inside our variable div. But if you want to calculate the accurate division result, you have to make sure that at least one of those two numbers is a double itself. Like for example this, double corrective is equal to 5 divided by 2.0, which is the exact same value as this, except 2.0 now forces this division to result in a double value and store that into our variable corrective. This would happen with any division that has only two integers in it. We'll talk a little bit more about this when we get to the casting very soon. All these operations can also be applied to variables themselves. Like if we have this setup, for example, where x is equal to 2 plus 3, which evaluates to 5, and y is equal to 4 minus 5, which evaluates to minus 1. So x has the value 5 in it, and y has the value of minus 1. Now we can actually multiply those two variables x and y and store the result in z. What this would do is it would multiply these values stored inside that two variables and put the result of that multiplication into the variable z, storing the value of minus 5 into this variable z. We can even combine more and more arithmetic operations into one statement. For example, if I wanted to calculate the amount of tip I should leave based on the amount that I've paid and the change I got back, I could just subtract change from that amount paid and multiply that entire result by 0.3, which is 30%. Notice that how I have used this set of parentheses around the subtraction here before I do the multiplication. This is to force the computer to apply the subtraction before it does multiplication over the result of that subtraction. So in this case, what would happen is paid minus change would calculate the value of 10.75, and then that result would get multiplied by 0.3, which would evaluate to 3.225, and that would get stored in the variable tip. So I know I have to pay $3.225 tip. But if I didn't have those set of parentheses, computer always prioritize multiplication and divisions over addition and subtraction, which means once it sees a statement like this, it would perform that multiplication part before it performs the subtraction, calculating the value of 1.275 and then subtracting that from 15, giving the result of 13.725. That's a big tip. So remember to always use those set of parentheses when you want your arithmetic operation to perform in certain order, because computers always try to perform multiplication and division before it tries to do any addition or subtraction. So if in doubt, always surround your operation with parentheses.